So welcome to AI with a human touch. My name is Torsten Schön and we are here at the Technische Hochschule Ingolstadt, especially at the AImotion Bavaria Institute. And this is not coincidence, this is the future hub for autonomous mobility. And we are inviting research community and our industry partners to come here, collaborate with us and test in Ingolstadt. And today we're going to look into a simple question: can AI-generated images be fair? So bias in text-to-image systems is not only a technical issue, it has real ethical consequences. So here in our research project, which is called Even Fair, we have an interdisciplinary team of AI researchers and also ethical researchers, and we are collaborating with TechHub by EFS. So I'm very happy that Venkatesh is here with me today. So he's a PhD researcher in the Computer Vision for Intelligent Mobility Systems group at the AImotion Bavaria Institute at the Technische Hochschule Ingolstadt. Yeah, and he's doing in his work studying the implications and the ethical implications, but also the technical requirements of bias and fairness in generative image systems. So Venkatesh, a very welcome. And I would like to start with a very, very simple question first. So if we speak about bias in generative models, what exactly do we mean?
So we have these really awesome text-to-image models like Banana, which is trending at this moment, and there is Stable Diffusion, which are really good at producing high-fidelity images with very realistic properties in them. But then these models are actually trained on uncurated data sets, which might have underrepresentation of certain class of demographics. And when we actually apply this model into production, they would tend to naturally generate images of a specific gender or a race with high frequency than the other one. So this might cause a lot of harm in the society if they are being used in a lot of use cases, like generating images for news article or something like that. So this is what we consider as bias in text-to-image model. This is one form of bias. There are still many more.
Okay, so can you give some examples of what would a typical user prompt and what would be a neutral prompt that leads to a biased output for these images?
So let's imagine we have this Stable Diffusion model, and we ask the model to generate an image of a nurse, and almost 100% of the time the model would generate an image of a white female that's in a hospital background. Although we know that there are a lot of female nurses around, but then if you actually look from the perspective of gender neutrality and all that, we might expect the model to generate nurses with a lot of demographics involved. Either it could be race, it could also be the age of the nurse that's in the picture, or the gender of the nurse in the picture. So this is like one example, and we have observed a lot of gender neutral professions. When we actually give them gender neutral prompt to these models, they are heavily biased towards one specific gender or race.
Okay, and what impact does this have on society?
So let's talk about using these models in a news article where people write some content and they want to represent a picture of, let's say, a CEO. And if the number of CEOs in that specific news article are only aligned towards one specific direction, if there are only like white men wearing all the coat and all that, it might offend the other group of demographics. And we would have to correct this bias to these models, and so that it gives a more fair demographic representation so that everybody's happy.
Okay, yeah, and it's obviously also enforcing this bias even further.
Yeah.
So detecting the bias, I guess, is pretty straightforward. Yeah, you can give some neutral prompts and then measure the gender, which probably is also not very easy, because you need to detect the gender in the right way.
Yes.
But if we speak about fairness, I guess it gets even more difficult because there are different understandings and different targets that you want to have for fairness. So this is why we collaborate with our colleagues, Professor Crompton and Professor Uhl. So what is their part in the project?
So yeah, of course, the concept of fairness is subjective, and one people might want 50-50 male and female in nurses, and some other people would argue that there are more female nurses here, and why should I have 50% male nurses? It's not as realistic as the real world scenario. And we have people in the ethics group, which is led by Professor Compton, Professor Uhl, and Professor Florian Richter, along with my colleagues here, who are doing some user study on a large group across a diverse group of people. They're asking questions like, hey, this is a profession, let's say firefighter, and what is your expectation of gender distribution on this specific set of professions? And they are performing this user study and giving us some normative rules that we have to set while assessing the fairness of a text-to-image model. Okay,
so before we dig into the details on how we can enforce this bias mitigation or fairness, let's start more general, and maybe you can tour us through the process of image generation. So what is actually happening when I prompt something, some text? How do I come from this text input to an image output showing what I wanted to get?
So this is like a huge field of research, but let's stick to diffusion and flow-based models for now. And, because many recent trending models are based upon this diffusion or flow-based architectures. And I would like to picture them as this messy artist who basically have this very noisy canvas, and this artist smartly remove the correct noise at the correct time to actually generate the very fine high fidelity images. And in a typical denoising image generator, we have a text embedder, which basically takes the user's text prompt and converts them into high dimensional embeddings. And then we have a denoising architecture, which basically starts with the random noise and then removes the noise step by step over a time period, and then eventually it actually generates very high quality images. And sometimes these denoising is actually done in a compressed image space. We compress this embeddings using a variational autoencoder, and then the denoising model works on this latent space, and then we use the decoder part of the VAEs to actually upsample the images to the actual RGB image space. So this is basically how a text-to-image model based on denoising diffusion or flow-based models work.
Okay, so this you spoke about embeddings. So embeddings is encrypted representation of information. So we take the text input, extract the information, store it in some kind of encrypted numbers, and then from these numbers we restore the image.
Yes.
So exactly. in this pass, where do you think is the bias encoded, or where is the best position to target the debiasing?
Yeah, so the first and the most easiest part to target is the text encoder itself. We could see that the embeddings or the latent representation for, let's say, like a gender neutral profession, like a doctor, could be aligned more towards the male direction than it is to the female direction. So we have to manipulate this embedding so that they appear more neutral or they are more diversified. So this could be like a first place to hit the model so that we could get some unbiased or fair representation.
So when you talk about is closer or is more distance between these two prompts, so I think we need to explain this multi-dimensional space. So if you have a vector of embeddings, this can be seen as a multi-dimensional space.
Yes.
And can you explain what you mean with distances and is closer to each other?
Yeah, so we have this metric called cosine similarity. So imagine we have this high dimensional vector. So Clip usually encodes your images or text into 728 dimensions. So this is like one specific architecture. So we have, let's say we have this high dimensional representation for a gender neutral word, 722 element vector, and we have another representation for female, and we basically like look for the cosine similarity, the angle between these two representations. So if they are really close to each other, we have a high similarity score, and if we have representations that are really far apart, we have a very low similarity score.
Okay, so this means if we would imagine like a room where all these embeddings are standing around, the female nurse would actually be much closer to the nurse term than to the male nurse.
Yes,
term.
exactly. Yeah.
Okay, awesome. Good. So you said this distances already, cosine similarity. So this is measuring the angle between these things, what we just explained. Is this the only metric that is used there?
There are also metrics like Euclidean distance, but in this context, at least for this extracting semantic concepts within the latent space, cosine similarity is one of the metrics that people more frequently use.
Okay, so and what is now the idea to do the debiasing there? Is it just like taking the one term and moving it to some other direction, or?
We try to extract the most relevant dimensions that represents a specific attribute. Let's say we have a specific dimension among this high dimensional space that represents the direction for the female, and something that would represent for this race black, and there is also intersection of gender and race direction. So we could try to extract these specific vectors and try to manipulate our neutral prompts towards one specific direction. So this is something that we are actually working on.
Okay, so what is the difficulty there, or what are the pitfalls? Because this sounds not too hard. So why has nobody, or why are the big players not doing that from scratch?
There are a lot of issues with this technique itself, because we cannot guarantee that it could work on every cases. Like for example, the text embeddings, it controls the properties within an image in a global way. So if we have a group of people, the method wouldn't actually diversify the individual people within the image, and that could actually also be one of the reasons why a lot of people might not prefer this technique themselves.
Okay, so is in general, if you manipulate these dimensions, would you say in general that the other attributes of the image, like the background and the profession and stuff, they are always preserved, or is there always a risk if we move things around to destroy these things as well?
So it also depends on the intensity with which we manipulate this embedding. So if we actually make the embedding move very close to the attribute vectors, we go out of the concept. So sometimes we have to stick to a minimal or very soft bias correction in the text embedding space.
So that would mean that if we change the gender from a female nurse to male nurse, it's no longer detectable as a nurse because the clothes is changed, the background is no longer in the hospital and stuff.
Yeah, exactly.
Okay, so where do you think is the sweet spot of correction? To not destroy the attributes but still have the debiasing in place?
So there is an empirical study that we did, and we could find a sweet spot for this based upon some empirical analysis. So in our experiments, we did that, and we actually found a really good spot at which this kind of correction basically works here. So it could be reported, and it's reported in one of the papers that we are working on, and hopefully it gets accepted somewhere.
Okay. Yes. So this is one of the recent results that make you optimistic that these things work, right?
Yes, exactly.
Okay. So we are here at the group Computer Vision for Intelligent Mobility Systems, also in the AImotion Institute. One of our main focus is autonomous driving, intelligent mobility. So how does this project fit into this autonomous mobility system? Also, our partner is EFS TechHub, which is a subsidiary of CARIAD.
So one downstream application that these text-to-image models have is something called as in-painting, and it's a very promising application. So if we have an image of an ego perspective of a car vehicle, we could like insert very realistic pedestrians within that specific view of the image. And if we could like basically diversify the pedestrians rather than just rely on whatever pedestrian that comes on the road when we record a data set. So we could like add more synthetic pedestrian in it, and the most recent models are becoming really good at more realistic insertion of this in painting of these objects on the road. So this is like very useful application that I can think of. Yes.
Okay. So do you think a similar approach could also be used to generate new training data for computer vision or perception algorithms? Because we usually have these long tail distributions where we have biased training data, where we always see a car driving in front of us, but there are some rare cases that we do not see.
Yes, so there are cases like a really small child walking in the middle of the road, and this is a situation that we couldn't see in actual data recordings. And there also could be like some sort of disoriented vehicle, a vehicle upside down. And these are concepts that are really hard to generate, and we could use these text image models to in-paint such situations on the road, and we could maybe train our data set on such a data set and then evaluate how they operate on like these extreme or black tail or black swan scenarios.
Okay, great. So in this interdisciplinary research team, where do you think is the best entry point to join research, or if there's someone out there who's more interested in this or wants to collaborate with the research group?
Yeah, sure. So there are a lot of aspects on this project. Specifically, there is like an ethics group that basically targets people, ask them questions and assess their answers and try to gather what the expected normative fairness criteria is. So that's one part of the project, that if people are interested in setting up a framework to gather this data, it's really nice. And there is another part where you already mentioned that we are like working on using some AI to identify the demographics present in the images that we have. And we have to somehow ensure that these AI models are actually fair enough in detecting these people, the demographics of those people. So that's another part of the project. And then if people are really interested in the image generation part, there are a lot of methods which already try to mitigate these biases in text-to-image models. So if people are really interested in these topics, there are several resources that they could like do, and they could approach us, and we could like easily collaborate on these ideas. Yeah.
Okay, nice. So having a look at it from a different perspective, so speaking about our students, so if some of them would be interested in joining this field of research, so what skill set do they have to bring in?
First of all, they should know how AI works. If they are getting into this field of image generation and also demographic detection, and they should have really basic knowledge on how to train an architecture, how do we test them, how do we like do some edge case testing. So not just like testing on one validation set, how do we like extend this and then try to see where the model actually breaks and what is our limitations of using this AI model. So we need people who already understands these concepts, and also if people want to get more advanced, we would definitely ask for some skills in diffusion models or denoising probabilistic models, which acts as the fundamental for image generation with the modern day architectures. Yeah. So yeah.
Okay, great. So this project is the Even Fair project is funded by the Bayerische Transformation und Forschungsstiftung. So we can also use the Bayern KI resources, because you know better than me, then training these models costs a lot of GPU power. Yeah. So how do you make sure that even with this reduced set of GPUs, compared to the big players working in this field, so that we can bring something to the community?
So obviously we cannot actually train these huge models from scratch on like a really curated data set. So we primarily focus on methods that work on a post hoc way. We do not modify the parameters of the model, pre-trained model ourselves. We just like use the existing knowledge of the model and then try to modify a very small part of this model, or try to do this, embedding manipulation techniques. And there are also some parameter efficient training methods like using low rank adaptation or LoRA technique, where we inject some adapters as an intermediate layers, and then we only train these intermediate layers with our fairness criteria. So this is how we try to manage this GPU crisis that the whole world has. So I mean, it's the best way that we could do with the number of GPUs that we have. But then the sizes of the models are also growing up and up, and we would still have to catch up on it. So there are also some quantization that we could do to actually infer these huge models on a very small GPUs. So these are some techniques that we do to manage our project within the limited GPU resources that we have. Yeah.
Okay, great, thanks. So let's start with more personal questions, to get to know you better as a person and as a researcher. Yep. So you're working with the Essex team now for quite a while. Yep. So how would you say did that change your way of thinking and your way how you tackle problems? Did this somehow affect your daily work?
So the working with ethics people, I mean, kind of changed my perspective on how we evaluate AI models. So usually when I try to evaluate something, I have this target metric and I only look at that. And then if we actually talk to some ethicists and some people who are working on this ethics concept, they have a lot of evaluation criteria. And then I got to understand what do I have to evaluate to understand the perspective of an ethicist in mind. And I'm trying to incorporate that in my workflow, and I'm doing it step by step. So
yeah, that's a good learning actually. Usually as a machine learning engineer, we are focused on satisfying the metrics, but usually there is some problem that we want to solve. We do not want to solve the metrics. So this is a great learning. Speaking about learning, so outside the lab and your daily work, so what do you do to stay balanced and stay up to date?
So at this point, I have a 1-year-old at home, and he takes up most of our time. But then I try to find the teeny tiny bits of time that I have and try to get myself up to date on the latest topics. And there are also platforms like ResearchCast, which is also one of our initiative. And I try to listen to some of these podcasts. So I try to generate these podcasts from the most interesting paper that I have, and then try to catch myself up with this research world. And I also try to do this as simple as possible, but then sometimes I have to dive much deeper. And most recently I had to learn through this concept of rectified flow, and it actually took me almost 10 to 12 days of reading through this stuff part by part, and also balancing between home and work. So
I mean, both of this, doing a PhD and raising a kid is both tough challenges, but they are on a different perspective. So for me, this always worked when I had a hard task at work. I came home, it was still still enjoyed. Even if you have to do stuff to get the kids to school or to prepare something. So it's also, you have to do a lot of work, but it's a different kind of work, and it's also very much enjoying. Great. Definitely. So let's do a quick round of questions. And I'm going to ask a question, and you're going to answer with just a very short, one sentence or one phrase answer. Okay? So first thing is prompt adjustments or post hoc methods. Which scales better across many prompts?
I think they're both the same. Prompt adjustments are also done in a post hoc manner. So I would say post hoc adjustments, of course. It's the best thing because it's the only possible thing that we could work with.
Okay, if something is not working, fixing the model or fixing the data first?
So usually I would say fixing the data first, but then the models that are being open source now have a proprietary data set and we couldn't fix them. So models are the default option these days.
Okay, what do you think is the biggest risk when we reduce bias in these models?
Overcorrection of biases. So we could like try to manipulate the vectors towards one direction, and then it could like give us very unwanted representations. So this could also be like we could also see this one in one of the blunders with Google Gemini earlier when text-to-image models were really new. It generated a lot of unwanted representation in a lot of bad contexts. So overcorrection is one of the problems that we have.
Okay, so if you would have one wish free for the image generation community, what would that be?
Open source the data set, release the training scripts.
Okay, so this is a great closing word. Venkatesh, thank you very much for this conversation. So this was AI with a human touch at Technische Hochschule Ingolstadt. If you enjoyed this meeting, and found this interesting, make sure to follow this channel and also tune in for the next one.
Thank you.
Thanks.